Welcome to the Energy Summit. This is our session on asset visibility and condition monitoring, brought to us by Moazzam Shamsi from Emerson.
Good afternoon or good evening to wherever you are in the world. There was a lot of great things that Matt and Roland were discussing there, and I think my relationship with Cisco goes a long way back, because for the longest time ever I've been kind of talking about IT and OT convergence even before it became kind of mainstream in the press. And that's why I was very keen in the early days for Emerson and Cisco to collaborate, because I always felt that in industry, there was a place for an enabling architecture and an enabling infrastructure. And just like Matt was sharing there, it's not just a single use case infrastructure, it's an infrastructure and architecture that's going to serve multiple challenges, solve multiple problems, right, and provide solutions across the facility. And I've been working with Cisco for many years now, and I've always kind of talked about this kind of industrial architecture and being able to provide that connectivity from everywhere, from the sensor to the enterprise, and now commonly we talk about it as a cloud. So being able to take that sensor data and all the way up into the cloud. Well, what are we trying to enable with this infrastructure? Today, I'm going to kind of concentrate a little bit on condition monitoring and think about really what do we do to kind of enhance asset visibility. So what do I mean by that? It's actually being able to give us better line of sight on what our process is doing or what our manufacturing facility is doing. Because if we get better visibility of it and better insight of it, we get the ability to measure something. And when we've got the ability to measure something, we've got a good chance of controlling it. So one of the areas that I'm going to touch on today, which is really common across the industry, is this whole challenge of sustainability. And I'll kind of use that as a little bit of an anchor point for and an entry point for kind of building up some solutions. Of course, Roland asked the question, where do you start, right? Well, Matt clearly said, yeah, it depends on the type of customer that you're dealing with, the type of facility you're dealing with, and the challenge that they're having in that point of time. But it's not only it's not only an existing facility, it could be a greenfield site as well. And the challenges for greenfield sites are very different to that of a brownfield site. But ultimately, you've got to kind of have an anchor point. And so my anchor point today was to kind of think about, one of those challenges, and it's the challenge of energy consumption, which is very, very commonly discussed today in the media and amongst all of the end users and people who manage facilities. So being able to identify where excessive energy consumption happens and understanding in my process and in my facility, what are those bad actors and how can I get better control? And without any visibility, you're not going to be able to really effectively implement an energy efficiency strategies. Now, where do you start with all of these is by actually identifying what your return on investment is. And sometimes when I get engaged with having this conversation, people think about IIoT and they start thinking about the industrial Internet of Things, and all I hear about is low-cost sensors. And I said, well, actually, the cost of the sensor is insignificant in terms of really the return of investment. So really what you want to think about is how you're going to use that enabling infrastructure, that enabling architecture, to really calculate what your return on investment is for the applications that you're going to roll out. Use that return on investment calculation to decide what you're going to prioritize on. To Matt's point, where's your starting point? What are you going to get? Where's the biggest return on investment? Or where's the best use case that you can visibly take back to the organization and demonstrate how that infrastructure is delivering value to the operation. The other thing is that efficient energy emissions monitoring is becoming a big thing at the moment. I'm working on a couple of projects now in India and also here in Europe, where there's a requirement to gather emissions data, aggregate that data across the fleet, and actually then report that data up into the cloud to government websites for regulatory monitoring. So there's this drive with regulations and gathering data, and to Matt's point, connectivity is the key here. If we can't connect, we're not able to satisfy those regulatory requirements, and we're not being able to report that data effectively. Also, changing climates in terms of business and also geopolitical events means that potentially those traditional feedstocks that we have may change. And so being able to monitor and manage these variable feedstocks really, and actually build a facility that's going to be able to kind of better monitor our process so that we can make better decisions about how we manage those feedstocks is critical. So these are some of the challenges, and I kind of wanted to start out by kind of laying out some of those challenges. But let's kind of take a little bit of a step back into the past, right? Step back into the past. And when, decades ago, when I went to a facility, it was very much, highly regulated architecture when we came to think about automation. It was very DCS centric, very PLC centric. And all of our data associated with our asset and those sensors were connected to a DCS system or a PLC. And that was a highly federated and managed architecture with very little opportunity to distribute that information across the facility. Fast forward to the present day, and with our architecture and the types of components that we've got that we can build up into our architecture, we can now build very secure architectures that go way beyond just the DCS. We're able to build enabling infrastructure and architectures that enable us to connect in new ways to the facility. It enables us to introduce new components into that facility, like edge compute, wireless sensors, and new types of connectivity that go beyond just wired Ethernet to Wi-Fi connectivity that Matt was going through earlier on. And, with that, it enables us to build a much more agile architecture. And really, what is that expectation that we have when we're kind of thinking about the architecture? Really, we want an architecture of technologies, right? So thinking about Wi-Fi, thinking about edge compute, that enables us to really manage that highly distributed data and really being able to give us comprehensive access to that data wherever we are in the facility, either be it through being physically connected to a network, to improving our situational fluency when we're in the facility. And, Roland asked earlier on, are people really doing this today? Yes, they are. People are going out there in the field today as highly connected workers, collaborating with their colleagues who may be geographically in a completely different location, being able to get better situational fluency when they're in the field. We've been working with end users where they've made tremendous savings just in commissioning savings alone as they're starting up their facility by the ability for them to have real-time access to that data in the field. And that's where the IT and OT collaboration between Cisco and Emerson has really worked. We bring to the table an understanding of process and the operation and how that operation functions and how those processes are managed. And with the Cisco partnership, they bring the wealth of knowledge from the IT arena to enable us to give those operators secure connectivity in the field. And importantly, with that connectivity is the ability for that facility to adapt and for that architecture to really be seen as an enabler for, as I've said, secure access or connectivity wherever you are. Now, pivotal to all of that is making sure that those functional requirements are defined. So if it's a greenfield capital project, getting early engaged in that project so that we can architect a facility that is actually fit for not only the present, but for the future, and is agile. The architecture is agile enough to grow and accommodate changes of technology. So getting those functional requirements and making sure that those are established is really important thing. And what we've done is that we've kind of taken this known problems, known solutions approach where there are very clearly defined problems today, and I'm going to share some of those with you today, and really being able to templatize those in terms of standard solution sets so that when a client says to us, well, where should we start? Well, we know that one refinery is pretty much as very similar to another refinery, right? They're going to be facing the same problems, and being able to kind of present those solution sets and saying, look, here's a standard solution, and we can kind of, that's fully defined and ready to roll out in your facility. So common connectivity challenges. So, when people are starting out on this journey, it's about how can you improve the connectivity for field personnel. And, Matt went through right the way through that, and he kind of laid out the story around ensuring that you get this kind of ubiquitous connectivity wherever you are. But it's not only about the connectivity that you're going to provide to that individual, but what are they going to do with it? Well, commonly what we find today, and what I've been working on with some, major energy providers, is that, how can you provide that connectivity architecture as an ability for people to collaborate so that you don't actually necessarily need to actually fly in all of your experts into one location. I've worked with a major upstream end user where typically like bed space offshore is a huge issue, right? Be it an offshore platform or an FPSO, flying people out to an offshore platform or an FPSO, you're always going to struggle for bed space, something that you wouldn't ordinarily think about, right? You'd think about all of the other challenges with getting somebody out to there, but actually having bed space somewhere for that person to sleep overnight is difficult. But actually having an architecture that enables connectivity from the beach, from anywhere in the globe, and being able to access an expert that could be remote with somebody who's situated in that offshore platform trying to diagnose a problem, that's going to save having to potentially fly an expert out. So being able to connect people out in the field in those sort of scenarios is hugely beneficial, and significant savings, not in terms of dollar value, but really about managing the resources that you have offshore and really thinking about, well, do I really need to fly that person on? So being able to it's not just about reducing personnel, but it means about how you can effectively deploy your resources and really only fly them out to places where it's absolutely necessary. Also, the other big thing is to really think about, how do you connect and share and distribute information that may be stranded or isolated? How do you create a secure enterprise where you can now move that data around the enterprise and actually, think about how, again, you can distribute that data into a mobile device, whether they're getting it through an app or even whether they're getting it through a web browser. How can you really create that kind of connected enterprise? And then, importantly, thinking about making sure that infrastructure, is fit for evolution, fit for supporting digital transformation. So that's progressively moving from digitization through digitalization and effectively onto digital transformation, where the nirvana for the site may be autonomous operations, where, you know, lights out operations of a facility. So how can you kind of manage that as you walk through? So that digital journey is about really thinking about how you kind of view that facility and create that connectivity all the way up from the sensor through the enterprise, and then effectively distributing through your facility. And really thinking about, when you think about the architecture, it's thinking about how would you architect it for your facility so that you create this parallel path for data that doesn't necessarily need to route itself through the core DCS system, but how do you route it around the edge? And, you know, in the automation world, there's a lot of talk around the Nomura architecture. So that's really essentially all about how do you route data around the edge, right? How do you avoid necessarily having to take it through the bottleneck of a DCS or a PLC, but actually route it around the edge and actually distribute it into the enterprise, into new sorts of applications that traditionally that perhaps you wouldn't have today. Things like today we can monitor corrosion in real time. That's not data that would normally be consumed by a DCS, but there'll be a corrosion engineer on site, and they'll be looking at that data. And the ability for us now to deploy real-time sensors down at the field device level, and then actually take that data up into analytics platforms that are going to give them real-time data so that they can make an informed decision about when to replace a piece of pipework is absolutely essential. So I put this slide up and it looks kind of busy. Yeah, go ahead.
Can you flip back for a second?
Sure.
I've been holding off because you've been just nailing everything here, and I don't want to stop the flow, but I do have a couple of questions. So first of all, this idea of going around the DCS environment, or maybe not around so much, it sounds like you're kind of trying to get away with something, but you're really creating a whole nother infrastructure that's much more cost effective, right? To get a lot more value, right, for something that might not make sense to do through a DCS system, right? So that's a really, really valuable idea. And there's a lot of people I talk to that just haven't really considered that seriously, right? You talked about a corrosion engineer, you've got reliability engineers, you've got maintenance, and like you've got so many different groups that don't necessarily have control systems in their environment, but they could really benefit from this type of architecture, right? So is that something that you're seeing pretty much across the board, that people are really starting to adopt that approach?
Absolutely. And, you know, it starts with the brownfield facility. And yeah, okay, maybe, you know, the words are, you know, being able to route that data and not taking it through the DCS because they're trying to get away with something, but purely because the DCS may not be able to provide them with the connectivity that they would want, right? It may not be able to support the modern day protocols that you would want, like OPC-UA or HART IP, right? And so being able to provide them with a secure mechanism for transiting that data to new types of applications that may not exist within that kind of DCS architecture, because what you want your DCS system to do is to really manage the plant and manage the control, you know, of your loops, you know, manage the process in the most effective way. Then your reliability engineers, your maintenance engineers are going to want to kind of look at the integrity of the asset. And so for them to have that data, not necessarily within the, you know, within that DCS architecture, but maybe up into L3, maybe up into L4, they could be, you know, anywhere in the enterprise, but being able to introduce those new applications as well. Now, if you were to try and introduce a new application within the architecture of the DCS, you may be violating architectural principles that your DCS vendor has put in place, and you certainly wouldn't want to compromise that. So being able to securely create this connectivity outside of that environment not only preserves the integrity of your DCS, because you're not you're not messing with that architecture, but it creates this kind of more agile way of connecting these new apps within your architecture.
That's huge. Yeah, no, thank you very much. I have other questions, but I want you to continue and go through some examples here. I think this is good.
So here's an example, and on that, and it's a little bit of a busy slide here, but what I've tried to do here is to kind of lay out those different levels of the architecture. And what we've got here is essentially the ability, what we're essentially illustrating here is that we've got our core process control system, and we've got things that are there just for regular process monitoring. That you've got your flow, your pressure, your level, your temperature, and you may very well enable those in your DCS architecture, even wirelessly, right? So you may introduce these wireless gateways into your DCS architecture to supplement monitoring today that's wired, but increase your visibility through wireless monitoring by integrating some of those wireless gateways. But then outside of that, we've got another secure architecture. So you can see that in that secure architecture, I've got my access points, which are enabling my mobile worker. And like Matt went through a lot of those kind of mobile worker examples. So being able to kind of manage not only my day-to-day operations, but also being able to manage those events that may happen on a periodic basis, like turnarounds and shutdowns. So you'll have a fleet of new people who come to site and you want them to have access to data. And that data may be data that's associated with reliability. I want to get access to the data on the performance of my pumps by looking at vibration monitoring. I want to get stranded data that's maybe in my valves to look at the performance of my valve, so I can take a decision as to whether I remove that valve for service during that turnaround and shutdown. So it's being able to give that data that's associated with reliability monitoring and opening up that visibility to a whole community of people who may not necessarily have had that. So that's kind of, like I said before, your reliability engineers, your corrosion engineers, people who are interested in managing the overall energy of that facility. So that's what I've tried to illustrate with this secure architecture and those multiple layers where we're now routing data into other places within the enterprise. So what are we trying to do? There's what I try to do here is to kind of look at this facility, and I talked about this kind of known problems, known solutions piece, to the point of where do I start? And this is really to that point of, well, find out what your return on investment is. Where are you going to get your biggest return? And the concept and the reality is today that architecture is an enabling infrastructure. We have worked with Cisco to integrate our sensor gateway onto the IW6300. So it provides a platform for not only mobile technologies like mobile worker, the ability to connect smart wireless, smart wearables, but it's also that very same infrastructure that we're using to gather data from these new types of sensors that are going to give us performance data associated with heat exchangers, performance data associated with pumps. So if you think about it, what I'm trying to illustrate here is an example of a facility where we provided that comprehensive monitoring. So let's walk through a couple of examples. Right, so here we've got a Southeast Asian refinery where they've not, their initial, starting point was, how can I create a connected workforce? I want to create an infrastructure where my infrastructure is not only being used to kind of track where my workers are through location awareness, but I also want to enable them with tablets so that when we head up to a turnaround or a shutdown, that I've got these fleet of new engineers that are coming to site and they don't have to rely on going into a control room, but they're enabled with that data into the field. Now, that very same infrastructure and that very same architecture has now been expanded to actually support field devices. So here's just a little bit of a snapshot of the architecture. So we had our Wi-Fi access points there, but they then subsequently integrated right on top of those IW6300s very soon after they commissioned the network with sensor gateways, which enable them now to get better insight into the field using wireless sensing devices. So let me just give you a couple of examples as I kind of head out to towards the end here. So I wanted to give you like a couple of big problems that there are for facilities, and just kind of contextualize it with really what the potential benefit is. So we kind of worked out the value model for this particular facility. This is a steam trap, and you go to any downstream facility and they'll have thousands of these across the facility. And the purpose of a steam trap is really to make sure that you get, you've got good steam integrity across the site, right? And that steam is used for many different things. But what you want to do is ensure that your steam traps eliminate condensate from the lines. And we can tell whether there's a steam trap that's bubbling or has gone abnormal through the use of this acoustic sensor that's attached to the trap. And what that tells us is whether the tap's in normal operation or whether there's a potential for that trap to fail. So the ability to kind of get some advanced notification of the impending failure of that trap. What it means is that we can get somebody out there to go and investigate the trap and actually intervene ahead of time. So using that enabling infrastructure that's not only being perhaps used for mobile worker, but enabling this acoustic sensor, which is just clamped onto the steam trap to actually get, to get that data. And what I've illustrated is, because I've said, return on investment is, well, what does it mean? It's not only maybe loss prevention. I've worked with a downstream company where they just equipped 100 of their 2,000 traps with an acoustic sensor, and they've got a use case where it's demonstrated $8 million of loss prevention at that facility. Wow. And here's one slide is, again, the same principle, energy efficiency across heat exchangers, no problem zone solutions. A lot of facilities, chemical plants, downstream refineries will all have heat exchangers. Big problem is fouling on heat exchangers. If you can use sensors to monitor the foul, those heat exchangers, you can take action early to prevent clogging and fouling, intervene, so you clean the heat exchanger, and that's going to save you a whole bunch of energy. And so I've illustrated that. And really, finally, what I wanted to head out here on my final slide is, and I was going to use this slide, really to demonstrate that actually facilities, and this is kind of a little bit of an Emerson slide, but I was actually going to use a little bit of the twist of this slide. It's about making sure that architectures are secure, right? Making sure that, there's no one vendor that can do it all, right? So we work with Cisco and other strategic partners to deliver that enabling infrastructure. So when you're thinking about your facilities, who are those key technology partners, right? Thinking about bottom right, connectivity, physical connectivity, wireless connectivity, but also the types of protocols that you're going to use to connect. So OPC UA, MQTT, REST. So thinking about those key elements and then really working with partners that are really going to provide you with that in-depth level of situational fluency. And as I said, I had many years of working with Cisco, who bring the IT experience, and I think we as Emerson kind of bring that OT experience and working together as a partnership really to kind of deliver that value. And with that, I just want to close out. Thank you for your time this afternoon, this evening, and this morning, and I'll hand back to you, Roland.
Thank you for joining us for this session. If this session was of value to you, please like and subscribe and click on the next video. Take care.